Good day, everyone! Are you ready to have fun with math? I'm your teacher, Jane, and let us make learning more fun. Before we start, here are some friendly reminders to keep in mind. Number 1. Stay alert and focus in the video lesson. Number 2. Prepare your pen and papers for the solutions of the activities. And number 3. Sit back and relax as you enjoy our video lessons for today. At the end of this lesson, you are expected to define direct variation. Show situations involving direct variation. Number 3, translate into variation statements a relationship involving direct variation. And number 4, solve problems involving direct variation.
Welcome everyone to our video lesson that is all about direct variation. In this lesson, you're going to learn how does direct variation use in our daily life. So I have here some examples of direct variation. So we have here a number of kilos of rice and the cost of it. If you are going to buy a high number of kilos of rice, therefore, you are going to pay a high amount of its cost. Then the second example here is all about the speed and the distance. So let's say you have an increase in speed. Let's say you have 6.5 km per 3 hours. Therefore, the distance you get is 19.5 km. In a contrary, if you have lessened your speed, therefore your distance is also decreasing. The third example is that if you have more time in your study, therefore, you will get a high score in your exam. And that's it. That is some example of real life situation that involves direct variation. So now let's have the definition of direct variation. A direct variation is a relationship between two variables x and y that can be written as y is equal to kx where k is not equal to 0. Here are some statements that can be found in the given problem. It can be y varies directly as x, or y is directly proportional to x, and y is proportional to x. It can be written in the form y is equal to kx, where y is the dependent variable and x is the independent variable and k is the constant of variation. For two quantities x and y, an increase in x causes an increase in y. Similarly, a decrease in x causes a decrease in y. So this is the condition that is related to the examples that I showed you a while ago. Now let us all determine whether the statement is direct variation or not. Number 1, we have tickets sold and profit of a concert. Is it direct variation or not direct variation? Okay, that is direct variation because we are going to analyze the statement. If there is so many tickets to sold, therefore, there will be an increase in profit of a concert. Okay, the next one, the number of hours to finish a job to the number of persons working. If you are going to analyze again the statement, if there are so many persons working to finish a job, therefore, the number of hours is going to be lessened. On the other side, if there is a few persons working, therefore the number of hours to finish a job is increasing. Therefore, that is not a direct variation. Now let us all translate each statement into an equation. Use k for the constant of variation. So we are going to translate those statements into mathematical form, which is in a form of direct variation. Remember that our standard form of direct variation is y is equal to kx. So now let us see. Number 1, C varies directly as B. If we are going to convert it into mathematical form or in a form of direct variation, it will become C is equal to KV. As you notice, our first variable in the statement is also the first variable in the formula, while the second one variable will become the second variable in the formula. In k, that is our constant variable. It cannot be changed. Next, number 2. M is directly proportional to n. Therefore, if we are going to translate it, it will become m is equal to kn. The number 3, we have a is directly proportional to the square of s. Therefore, the answer will become a is equal to ks squared. Okay, next, another example. We have the weight of an object is directly proportional to its mass. If you are going to translate into mathematical equations, it will become W is equal to Km. W is for weight and M is for mass. Okay, next we have the distance traveled by the car varies directly as its speed. So therefore, the variable here is d and s. So now, the answer will become d is equal to ks. Next, an employee's salary varies directly as the number of days he has worked. So therefore, okay, the direct variation here is s is equal to kd. Okay, it's very simply right. So now let us deal with direct variation. As you remember, we have the standard form which is y is equal to kx, wherein k is the constant of variation that relates to variables. Considering we have k is equal to 2, that is our constant of variation. So all we have to do is to represent the value of x and y in a form of a table. So since the value of x is already given, we're going to find the value of y by using the formula. So our given is the value of k, which is 2, and the value of x. So therefore, in our solution, it will become y is equal to 2 times 1 is equal to 2. Okay, next, number 2 is y is equal to 2 times 2 is equal to 4. 2 because the value of x in the table is 2. Therefore, if you multiply the two number, it will become 4. Okay, the last one, we have 2 times 3 is equal to 6. So therefore, if you are going to multiply the two number, it will become 6. Okay, in order to check your answer if it is correct, you need to use this formula of finding the value of k. K is equal to y over x. Since you are already get and find the values of y, you can substitute the given to this formula. So we have y is equal to 2 over 1. So to divide 1, the answer is 2. And that is correct. Next, 4 divided by 2, the answer is 2 also. And 6 divided by 3, the answer is 2 also. So now let us all determine if the table below express a direct variation between two quantities or not. So remember our formula of finding the value of k. So we have k is equal to y over x. As you can see in the value of x and y, you will notice that all the numbers are increasing. So now let us determine whether the given values is a direct variation. So you're going to substitute the value of y and the value of x into the formula. So 8 divided by 4, the answer is 2. 12 divided by 6, the answer is 2. And 16 divided by 8, the answer is 2. Therefore, the value of these three paired numbers are all the same, which is 2. Now, we conclude that this table is a direct variation. Okay, next, we have this value. We have x. The value of x are 2, 5, and 10. And then the value of y is 30, 25, and 3. Using the formula, we have k is equal to y over x. So therefore, substitute the value. We have 30 divided by 2. It will become 15. And 25 divided by 5, the answer is 5. Then 3 over 10, the quotient will become 0.3. Therefore, as you can notice, the value of its k, is not the same. So 15, 5, and 0.3. Therefore, we conclude that this table is not a direct variation. So now let us proceed to the situational examples of direct variation. In outer space, the distance an object travels varies directly with the amount of time that it travels. If an asteroid travels, so this is the asteroid, travels 3,000 miles in 6 hours, what is the constant of variation? So we need to find the following, the constant of variation and the equation of variation. So I make some tables here to represent the time and the distance of the asteroid. So the first step is you need to apply the formula. So we have B is equal to KT. Why B? Because it pertains to distance and T is for time. Then K is our constant variable. So the second step is you need to substitute the given values to the formula. B is 3,000. That is why 3,000 there is a 3,000 here. And we have K. Okay, just copy K, our constant of variable. We have 6, which is the time. Okay, now. So next step is think a number that can be divided to both 3,000 and 6. So therefore, in order to cancel out this number, you need to divide it by to the same number. So we have 6,000 divided by 6 is equal to K 6 over 6. So therefore, cancelled out this one. So it will become 6,000 divided by 6 is 500. 500 is equal to K. Now, I have here the representation of tables that pertain to the time and distance of the asteroid. So according to the problem, the distance of the asteroid is that travels is 3,000 per 6 hour. So the first thing you need to do is to follow the formula and rewrite it in the correct one. So since our D is the distance and T is for time, then our K is our constant variable. So the next steps you need to do is to substitute the given information of the problem into the formula. So we have distance, so D is equal to 3,000 and T is equal to 6. In order to find the value of K, all you need to do is to divide both sides by 6 in order to cancel out this number. So therefore, 6,000 divided by 6 is equal to 500 and 6 divided by 6 is 1, invisible 1. Therefore, 1 times K is equal to K. So now the value of our K will become 500. And now if you already get the value of K, all you have to do is to substitute the value of K into the formula. So therefore, our equation of variation will become D is equal to 500T. Okay, our next example is all about the electric bill and the number of fans. So the cost of electric bill directly proportional to the number of fans running in the house. The cost of electrical bill is 1,050 and the number of fans is 5. Now find the variation constant or the constant of variation and the equation of variation. Okay, this is our solution. So the same with the problem in the asteroid, all you have to do is to follow the formula and rewrite it in the form of the given. Okay, we have E for electrical bill is equal to KF, which is the number of fan. So next step, substitute the given. So we have 1,050 is equal to K over 5. Then, what's next? So divide both sides by 5. So 1,050 divided by 5 is equal to K over 5 divided by 5. So now the variation constant will become 210. So the value of K is 210. Then substitute the given values into the equation. So it will become the equation of variation will become E is equal to 210F. Okay, that's it. So let's try another example. So we have M. If M varies directly as N and M is equal to 100 and N is equal to 15, find the variation constant, the equation of variation, and we have here the condition, find the value of M when N is equal to 3. So the first step, you need to write the formula. So we have M is equal to Kn because that is our given. Then substitute the given information into the formula. The value of m is 100 and the value of n is 15, wherein k is the constant variable. Then divide both sides by 15 in order to cancel out this 1. So therefore, 100 over 15. So since this is not a perfect number, all you have to do is to find the factors that can be divided both numerator and denominator. So what is the number? So that is, we are going to divide it by 5. Okay, so 100 divided by 5 is 20 and 15 divided by 5 is 3. Therefore, the answer here, if we are going to simplify this number, is 20 over 3. That is the value of k and the variation constant. So therefore, substitute it to get the equation of variation. So it will become m is equal to 20 over 3n. Okay, since we have the condition, find the value of m when n is equal to 3. So we are going to use this equation in order to find the value of m. So use the equation. So we have m is equal to 20 over 3n. Then substitute the value of n, which is 3. So it will become 20 over 3 multiplied by 3. So all you have to do is to multiply 3 to the numerator and just copy the denominator. So therefore, it will become 3 times 20. It will become 60 over 3. So therefore, the answer will become, the value of m is 20. Okay, our next example is all about the Mars. The weight of an object on Mars is directly proportional to its weight on Earth. A man who weighs 120 kg on Earth weighs 20 kg on Mars. Find the weight of a man on Mars if he weighs 96 kg on Earth. So now let's see the solution. Okay, so you need to follow the formula, which is W pertain to the weight in Mars and E is for the Earth weighs. Okay, so the value of W is 20, then our E is 120. The first thing we need to do is to find the value of K, or the variation constant. So next one is divide both sides by 120 in order to cancel out this one. So 20 divided by 120 is equal to K, 120 over 120. Since this is not perfect numbers, all you have to do is to find the factors that can be divided both numerator and denominator. So our factor here is 20. So 20 divided 20 is 1 and 120 divided 20 is 6. Therefore, our variation constant is 1 over 6. Then our equation of variation, just substitute the values to the given equation. So it will become W is equal to 1 over 6E. Then, the last question is find the weight of a man on Mars if he weighs 96 kg on Earth. So let us use this equation in able to get the value of weight of a man on Mars. Okay, our W is equal to 1 over 6E. Therefore, all you have to do is to substitute the weight on Earth of a man, which is 96 kg. So therefore, all you have to do is to perform the indicated operation. Multiply 96 to 1 and just copy the denominator. 96 divided by 6 is equal to 16.
There you have it. Always remember, in order to learn mathematics